Good day from Chem Help ASAP. We will now discuss performing solvolysis reactions on alcohols. And we've already talked about this with halides. And just to be clear, these reactions, these solvolytic reactions, are typically SN1 reactions. So what did we see on halides? For halides, we had some kind of alkyl halide, and the halide was a good leaving group, so that halide left, and we formed a carbocation. Note that we're making a nice, stable tertiary carbocation in this case. And once we form the carbocation, carbocations always undergo two fates. They either get attacked or they're going to lose a beta hydrogen. And since we're talking about an SN1 reaction, a substitution, we're going to get attack on the carbocation. And we're going to have attack by our solvent. It's a solvolysis, so the solvent will participate in the reaction. It is weakly electron rich on that oxygen. In this case, we have methanol. It attacks the carbocation, and then we get the solvent molecule attached to our parent alkyl group. Now really, the SN1 reaction is done at this point. The first step is step one, we made the carbocation. Step two was the attack on the carbocation. But for these solvolysis reactions, we have to add a third step, and that's where we remove the extra proton from our methanol solvent. And we'll use our solvent again, not as a nucleophile this time, but as a base to deprotonate. And we get our alcohol, and this went through an SN1 reaction. So how does this work on alcohols? Because we don't have a leaving group. Well, the conditions, first we have an alcohol. Instead of a halide, we have an alcohol. And the conditions are remarkably similar. We have a polar protic solvent. What we do differently is we will add some acid. The most common acid is sulfuric acid. Now what happens when you mix sulfuric acid and something like methanol? You tend to protonate your solvent. So sulfuric acid reacts with our methanol, the methanol deprotonates the sulfuric acid, and this is actually our functioning acid. So even though we have sulfuric acid on the arrow, what's really in there is protonated methanol. And this is our acid that will protonate our alcohol oxygen. Okay, that was a lot of work. That's a lot of work to say we're going to use acid to protonate our alcohol, and now we have a good leaving group. And now it looks just like the top reaction. We have a leaving group. It's not a halide, but it's a water molecule. We get a carbocation. That carbocation will then be attacked, and we'll continue our pathway. I won't show the whole thing, but what we get in the end is our solvent attacking our carbocation. So there are a couple things to point out. This solvolytic reaction on alcohols is still an SN1 process. We made a carbocation, which we then attacked with a nucleophile, our alcohol, our solvent. And another thing is we have an acid in here. So what acid do you use? Almost always people use sulfuric acid or phosphoric acid, H3PO4. These are acids that when they are deprotonated, they form very weakly nucleophilic conjugate bases. So the conjugate base in this acid-base reaction is this anion. It's called bisulfate anion. This is a really weak nucleophile. It's important for your acid not to generate a strong nucleophile because that nucleophile could potentially react with your carbocation here in the middle of the screen. So you tend to avoid things like HCl or HBr because those generate halide nucleophiles. Bisulfate, however, is a nice non-nucleophilic anion, and so sulfuric acid is a good acid to use for this. So you'll see things like sulfuric acid and phosphoric acid, and those acids are often a clue when used with a solvent that you're going to do some kind of SN1 solvolysis on your alcohol. But again, remember, we need to perform this reaction with a alcohol that will form a stable carbocation.